Like I say, we're going to look at reactions of alkenes today. We did a little bit of bonding yesterday. Can you just remind me very quickly, okay, what did we find out about bonding yesterday? What were some of the things we found out?
Double covalent bond is a pi bond and a sigma.
Okay, so we had a sigma bond and a pi bond to make our double bonds, okay? Hopefully, you've got it in your head, okay? My beautiful artwork. What kind of a bond is this one? Huh?
Double.
No. Well, that first part of the bond.
Sigma.
Sigma bonds, okay? And then this. Look at that for some artwork. What is this part then? That's the pi bond, okay? So you've got in the middle sigma and this two parts of one pi bond, okay? And that overall makes the double bond, okay? What did you find out about the characteristics of a double bond? What can it not do, for instance? Go on, Angie. It can't rotate, okay? Those p orbitals that make the pi bonds, they need to stay parallel to each other from the two atoms. So they can't rotate against each other. So a pi bond is stuck in place. Thinking back to what we did a few lessons before, what does that actually lead to? The fact that pi bonds are stuck in place. That led to a type of isomerism, didn't it? Go on. Geometric isomerism, exactly. So cis-trans and EZ isomerism all come about because of double bonds, sigma and pi bonds. Okay, but what I wanted to look at today is about reactions of alkenes. You're going to possibly remember some of this from GCSE. Okay, I'm hoping it works. We've got some wonderful new bromine water made today. Let's see how stinky it is. Oh, yeah. Whoa. Okay, don't get too excited by the bromine water and get too close to it, okay? Definitely don't stick your nose in it and inhale. That would be a bad idea. Yeah, it's my best safety advice for today. What I want you to do, we want to do a little comparison between what happens with bromine water and cyclohexene. And hopefully, what do I have here? Cyclohexane. Okay, so we've got an alkane and an alkene. All you need to do is to get two test tubes, a little bit of each of the alkane or alkene, a little bit of bromine water, shake it together, see what happens. Okay, and see if there's any difference between the two. You hopefully did something like this at GCSE, yeah? I think we tried to do it last year in Triple Science. Did it actually work? No, I don't think it did actually. I think I did it. Oh, okay. Did it work? Did it? Oh my God. I did some chemistry that works. Amazing. Hang on a second. What the reactions actually were, okay? But what I suggest we do, if one group can bring me their test tube rack, but everyone bring me their test tubes so we can get them out of here. Okay? So one test tube rack, but all the test tubes, please. Thanks, Maria. And then, that's okay, test tube rack over there, it's fine. Thank you very much, Genevieve. That's quite a cool one. Yeah, pop those in there, yeah. Perfect. Thanks, here we go. One more set. How have you got 4?
Don't know. One of us might be asleep.
One of you might be asleep. So, that one's got a bit in it anyway. Put that one back in the black tray, Pranesh.
Yes, sir.
Thank you. That one can go back with the test tube racks over there, James. Good.
Black.
Oh, okay. I need to leave that here. Well spotted. Pop them in there. Leanne, can you do me a little favour, please? Can you pop that back where it came from? Perfect. Janavi, do you think you can put that clamp in the right place so I can get past? Not totally confident. Yeah, I did. go. Oh, sorry. Go on, pop them in there. Thanks, yeah.
And the easy one is definitely D equals D over T. Okay? Now, to do this, how are we going to
Think the chemicals back again. Before my room really smells.
So I still agree for them to move that way.
Alrighty. Still smells a little bit in here of those chemicals. Oh, ooh, fresh air. What's wrong with you? Alright then, folks. So, what I wanted to do was just basically work out what was happening in those reactions. Alright? Pop this one on again. Assuming that we're done with that, let's work that out. Who's actually going to tell me? What's the molecular formula? Abdullah? C3H6Br2. Good. What about a displayed formula now? Rather than you come up and do it, I know you probably won't want to be on the video, that's fine. Maybe describe it to me instead. Leanne, go on.
So the first you have 3 carbon atoms.
3 carbon atoms, yeah.
For the 2 on the right, they have one of them have bromine for each one.
So one of them has bromine there, and then where does the other bromine go?
And the other one in the middle.
The one in the middle, okay.
And then the rest are all hydrogen.
And the rest are all hydrogen, exactly. 6 hydrogens altogether. 1, 2, 3, 4, 5, 6. Okay, so someone else. Pranesh. Yes. What is the name of this wonderful compound we have made? Exactly, 1,2-dibromopropane. Dibromopropane. Okay? And the pattern will just follow exactly the same all the time. Okay? There is nothing difficult in that. Okay? So we've just worked out our first type of addition reaction with alkenes. Okay? Decolorizing bromine water. Yeah, I'm not going to tell you much more than that today. It's 12:40. I guess as most of you have been here for an hour and a half or so, it's probably a good time to just cut our losses and stop right there. Okay?